Hello, today I want to tell you how I made these images. And so on, so on, so on. Yeah. So the first thing you're gonna need is to go to blender.org and download a fresh build of Blender. And Blender is a 3D modeling package uh, which contains some additional features um, like render engine, uh, path tracing render engine called Cycles, uh, real-time render engine called Eevee, and so on. So much stuff. You can use it for many purposes, but what I'm going to show you today is mainly procedural texturing and procedural volumetric um, shadering. And I want to point out that I'm not going to use the latest version because it doesn't support my GPU, but uh, it's better if you use it. It's going to be a lot different in aspects, especially graphical user interface. They almost written from scratch, so it may look different for you, but you'll find everything I'll show you. You can easily Google and find in 2.8. I'm going to use 2.79. Okay, so you had to download Blender. You'll move to the download page where you just have to press one button. If you don't like installing software like me, you can scroll down and go to Get Blender Experimental, because this page, it doesn't have an installer. It uses just some kind of portable version. Basically a build in a RAR archive or zip archive, I don't remember. Well, so whatever you choose, make sure you have some version of Blender 2.8 or 2.79, like I do. If you want the exact, if you want to repeat the exact steps as I do, don't want to Google anything, you can go to previous versions, and here you will have 2.79b. I think this is what I use, and yeah, this is it. You just have to press here and you'll get the build I'm using. So let's start. So this is what Blender 2.79b looks like, and whatever you're using, make sure you follow these steps. Go to File, User Preferences, to the System tab, and make sure you have in CUDA devices your GPU. Make sure it is set to CUDA and your GPU is checked, and click on Save User Settings, close this and go to render device. You have CPU selected here, most likely. You have to switch it to compute. This is going to give a much better performance when rendering. So unless you have a very old GPU, but it is most likely not supported by Blender, so you won't find it in user preferences. So after these steps, you see a default cube in the viewport, and to rotate around it, you have to hold your middle mouse button and drag. So you won't have this window, you won't have it like I do, and to open it you have to move your cursor down here, drag and drop here, and you have to switch, click on this button, which is the selection of window type. You have to switch it to 3D view, and you can navigate middle mouse scroll to zoom in, and middle mouse drag to pan around. And this cube, we are going to need it. So everything is set up. Also, we can get rid of the timeline. We are not going to need a timeline in this tutorial, so we can move you can move your cursor down here, hold and move down until you see this arrow and release. It's going to disappear. Now you have everything set up. You can also press T to get rid of the tool panel on the left. So everything is set up. Now you can switch this window type to node editor, which is what we are going to use for most of the time here. Now every object, like this cube for example, it has something called a material, and a material is basically a program that is being executed for each pixel of a rendered image on this object's outline. So whenever you apply a material to a cube, everything that's around the cube, it's not going to be touched by the cube. It will be filled with material. So let's start. On the Properties tab on the right, you have a lot of tabs that do different things, but what we need right now is Material tab. And with our cube selected, if I deselect the cube and select a camera for example, we don't have the Material tab. So make sure you have the cube selected. Go to the Material tab. Oh, by the way, I didn't explain how to select things. Hold on. One more thing before we move on. You have to go to Property, User Preferences, Input, and select. By default, it is set to right, or you have to select with left. but it is only applied to Blender 2.79. In 2.8 they changed it to to the left by default. So if you're using Blender 2.79 for the same reason as I do, because your GPU is not supported in 2.8, and GPU is much faster than CPU, you have to do it as well. And with left click you will select object. To deselect you have to hit A, and make sure your cube is selected. Go to the material tab, and here you will have the default material. We can use it, we can remove it and create our own, it doesn't matter, but all we need to do right now is click here, use nodes, and we need to switch our node editor to material tab. Node tree type to display and edit shader nodes. Yes, this is what we need. And this is a representation of a program that is going to execute for all pixels that our cube takes, and to switch to rendered mode you have to move your cursor over the lever tool shelf and scroll it until you see this sphere icon. You have to click on it and switch to rendered, and this is what you're going to see. Also, don't forget to switch to cycles render. This is important, and then you'll see this. By default it may be set to Blender render, and this is not what we are going to work with. You have to be in cycles render. And also, if your Blender render engine is set to Blender render, you won't have nodes, use nodes here. You'll have to switch to cycles, and then it will appear. You'll have to click on it and you'll be fine, like this. And this is the default diffuse shader we have here. It means that the light won't be reflected in any way. It may have reflexes, but it won't be reflected. And we have many of those. If you go to add, you'll see a lot of shaders here. One of them is glossy, which means that we are going to reflect, and the roughness is going to tell how rough our surface is, which determines the factor of reflectiveness. Zero roughness means it's perfectly reflectable like a mirror, and one roughness is going to mean that it is almost like diffuse. You'll see very little difference. It's a bit darker, yeah. Let's go to world settings and make our background color a bit darker. Now what we are gonna play with is none of these shaders, at least not right now. We want the emission shader. which doesn't have any shadows. It's going to display everything that you plug into the color input with a string of a string specified below. So what we can plug, by the way, to add a node, you don't have to go to the lover toolshelf view. You can just press Shift A. A stands for add. So Shift A, shader emission. Yeah, and connect it by dragging and dropping your left mouse button, and you'll be right. You'll be fine. So but we are not going to use all these tools. All we're gonna use is just about 10 to 20. So let's start by learning what these textures do. Let's see what is Voronoi texture. And we have the color output here, which we can plug into the color of the emission shader. If we had a diffuse shader, everything would be shaded. We have a light here. So when we use emission shader, the light doesn't affect our cube at all. The cube itself emits light, so which is why we are using the emission shader. We want to see the texture from all sides. Now if you click on Shift A, input texture coordinate, you're going to see a lot of different options that you can use, but by default this uses generated texture output. So if nothing is plugged into this vector, it chooses generated. So if I plug in generated, it's not going to change anything. As you can see, nothing has changed. So what if we take a look at those coordinates somehow? A vector is basically a set of values as well as color. Set of three values, x, y, and z, and color is R, G, and B. So what if we do this? So we can see this nice rainbow colored cube. And why do we see this actually? So let's take a look at each channel separately. For the X plugged in R, we can see the X-axis is directed towards right, and the closer the point, the pixel is to the right, the more red it gets. So if I plug in a Y to the R, it's going to go there. So if I plug in Z to the R, it's going to go up, right? So I'm just showing you the basics of what this stuff actually does. So this is just generated coordinates. They are always, for any object, go from 0 to 1. But we have a lot of other options here, and one of them which we are going to use a lot is object, and this one is a bit different. You're going to see it, it will be twice. The texture is going to, let's plug this back in. So we have generated now, and when we plug object in, we'll have everything scaled up. It is going to be twice as small. Look. And why is that, you may ask? And this is why we want to take a look at the object coordinates, and we'll just plug them directly into the color. What I did before is just to show you what it does. And so let's separate it again and combine RGB. So the red channel is black, completely black. On the x-axis, to the left of the middle. Same goes for y. It's black, and same goes for z. And why is it black? Maybe because z is 0 for all of this? No, it's not, because it's negative, and colors cannot display negative coordinates. But if we do some math to it, we can show, but it doesn't matter right now. What I want to explain to you is that we have the object origin at the center, which means everything towards the direction of every axis will start at 0 at this origin. This is the object coordinate system, and everything below z, below the origin, it's going to be negative z. Towards the left, it's going to be negative x, and towards y, it's going to be negative y axis. And here we have a unit grid which shows us the units. This is meant, 1 square is 1 by 1, which means that our cube is 2 units long, 2 units high, and 2 units deep. So this is why we have it twice as small, the texture, the scale is twice as big, and the texture is twice as small as it was when the generated output was plugged in. So, and we plug in object coordinates, we have it twice big. And why would we want to use object and generate it? We don't care right now, okay? maybe I'll explain it to you in the next video, but you should be aware how it works. Or maybe I'll say a couple words. Very often we need our 0 point right in the middle of the object, and generated coordinates will never give you 0, 0, 0 right in the middle. They are here 0, 0, 0, always on the corner, and this is not something we often need. So that's all to it. And now the fun part begins. Let's dive into the volumetrics. If you disconnect this, you'll see completely white cube, and the color will be whatever you choose here. But the flexibility of Blender is that you can plug in the same emission shader not just into surface but into volume output, which makes magic things to it. Since we are using a path tracing rendering engine called Cycles, which uses approximately correct physics, light physics, everything that I told you about the pixels that are being rendered doesn't always work as you may think of. Cycles actually emits a bunch of rays that go into your camera, and this is how you see the picture. It's a very rough approximation of what it does. It is not exactly so, but as a beginner you can imagine it like this. And what it does now is it splits cube into a bunch of smaller cubes called voxels, and from each one it takes its emission into account. So if we turn the strength down, you will see that we see the cube completely transparent. Cool, huh? This looks like a fog or something. But what about these textures? How would they work with volumetric emission? Let's find out. Let's plug the color of the Voronoi texture into emission. Let's turn the scale down to 1 and look at it. Wow, it looks 3D, and it is 3D because every texture you see here is not 2-dimensional, it is 3-dimensional, and in Blender 2.8 it is going to be 4-dimensional. It will have the option of 4 dimensions to be able to change it continuously with time. For example, to simulate clouds. Not simulate is not a correct word to describe it. It is more like a imitate clouds, okay? So what I just told you is uh, one of my most exciting discoveries in Blender. Every texture you can see here is three-dimensional. For example, let's take a look at the checker texture, and you can see interesting looking stuff, but the color too is not completely black, so let's see what it looks like if it is completely black. You can see it missing some parts. So basically it emits light from all of the parts inside the cube that are not black. Okay, so if we change it to a different color, you will see a different color. This is awesome. And what we can do with it is basically unlimited. It's only limited to your imagination, and I'm going to show you all the nodes we are going to use today. One of them is separate XYZ and combine XYZ. You already saw those two, and the other one is math, which is extremely important. It has everything we need to make awesome things with this Blender tool of procedural textures. Also, we are going to use a couple other textures like noise texture, which is it is a bit different from Voronoi. Let's crank up the scale of Voronoi texture and plug the noise texture instead, and you'll see that it has some color to it. So every channel, let's separate RGB, every channel is a separate noise texture, and this is basically what is called a Perlin noise, named after Ken Perlin, who invented this in 20th century, and it's basically a fractal of overlaying noises with different amplitudes and frequencies to create this image. But in Blender it is much better. It is three-dimensional. So this Perlin noise is three-dimensional. The other tool we are going to use from this toolset is color ramp node, and it is located at converter tab. We select color ramp, and we can drag and drop it over the connection to put it in between. And what we can do now is tweak the effect. So what was previously black, what was previously white, will be now white in the middle. So something like light gray will be black right now. We're altering this color, and something that was dark light gray and dark gray. Something that was light gray will be white. Something that was dark gray, darker than this one, will be black. And everything that is beyond. So this creates a nicer contrast to see our noise texture. And let's play with it. Let's put the scale to 3 and zoom in. And let's set detail to 10. You'll see that it gained some cloudy look when we set the detail to that, but wherever is beyond 12 is diminishing, which means you won't see any improvements beyond the level detail of 12. So don't try to set high values. And the last piece we are going to use is the gradient texture. And the gradient texture, we'll use object coordinates for this one because you can see the linear gradient starts from 0 to 1 and goes towards 1. And we have a couple more options here. Oh, for example, if we plug in generated, it will go from negative x to from negative x to positive x, and our cube will be completely covered with this transition. And if we switch it to radial, you'll see this kind of pattern. Starts at 0 and goes all the way to 1 in a 360 degrees. If you switch it to spherical, which is what I'm going to use for the rest of the video, you'll see that we have a small sphere in the middle with a radius of 1. And if we switch to generated coordinates, you'll see that the sphere center moves to the 0, basically to this point, because this is how generated coordinates work. Let's do this to demonstrate. Yep. So how we can use this together with math and color ramp and possibly Voronoi texture to create something like this, or maybe this. Well, we can plug the color ramp in between the gradient texture and the emission shader and change some of the settings. We won't try to play with a different color model, and color model we are going to play with is HSL, and we're going to set the interpolation to 4. And if you don't understand what I'm doing, just wait for a bit. So whatever was black before turned into red, light gray, all of this business, it just remapped the grayscale value into this space. Which made it rainbowy looking. And the last, I forgot to add another node. Here I'm going to use is mapping node, which is going to alter the look. For example, we can shift the coordinates if we plug into the gradient texture, or we can scale them up and down. So when we increase the scale, it becomes smaller. So after a bit of play with this, we get something that looks like this. If we zoom in, we see some kind of rainbow. And I didn't decrease the strength of the emission. Let's set it back to 1 and see what it looks like. Wow, it's already not looking too bad. I'll reset the scale to 1, and this is what we see right now. So how can we alter this? Maybe we can multiply it somehow with a Voronoi texture. So let's add another color ramp, plug the Voronoi in, and put the color into the strength. This is what we get. Let's alter it. We can get a crisp edge if we switch this to constant. Sorry. So this is what we get after playing a little bit with procedural textures. Now the other thing we can do with this is invert. We have an invert node in color, I can alter the factor of inversion. So one of the cool things about Voronoi texture is that each volumetric pixel here tells the distance to the closest point, as the closest generated point of the Voronoi grid. And what we are doing here is we basically saying whatever is greater than point 2, this is point 2, it is going to be white. Whatever is less than 0.2 is going to be black. And we can replace this with a math node that does the same thing by saying greater than 0.2, and it's going to do the same thing. We can play with this however we want. There's so much stuff to cover, and it already took me 50 minutes. So probably it is enough for a video. I hope you liked it. So goodbye. Thank you for watching, and see you